Hi. So for today, we're going to look at now solving equations, but we're going to look at it a slightly different way. So today is the 15th, and we're going to be solving quadratic equations, which we have done before, but now I'm going to show you a slightly different strategy for it. So if you recall what quadratic equations are, that would be something like x squared plus 3x plus 2 equals 0. And the way that you would have done that before was to factor and then solve. What I want to do for just a second is take you back to solving equations the normal way. So if I were to give you something like 3x plus 8 equals, 20. Okay, you know to subtract 8 on both sides, the subtraction property of equality. That would give you 3x equals 12. Now divide by 3 on both sides, the division property of equality, and get x equals 4. Okay. Think about the idea of why we subtracted 8 on both sides. 8, of course, was the additive inverse of positive 8. 3 was the multiplicative. Dividing by 3 is the multiplicative inverse of multiplying by 3. Okay. So if we go back to the quadratic equation idea, and we look at something like x squared equals 36. Okay, when we solve equations, we are always using inverse operations. Now there are really two ways to solve this particular thing. Because it's x squared, I consider it a quadratic equation. The way that we're used to solving quadratic equations is we would subtract 36 on each side. So I could subtract 36 on each side, get x squared minus 36 equals 0. Now I should recognize that as the difference of perfect squares. So it would be x plus 6 times x minus 6 equals 0. Set each of these factors equal to 0. And get that x is negative 6 and positive 6. Okay? But there's actually a slightly quicker way to do this. And I'd like you to recognize that that was difference of perfect squares. There is no regular x term, just x squared and a number. So let's quickly look at, again, if I was given x squared equals 36, since the x squared term is alone, there's something very quick that I can do here if I think about solving as the opposites. Well, the opposite of squaring something over the past couple of days we should have seen is to do the square root. So if I were to actually take the square root of both sides, because what I do to one side I have to do to the other. The square root of x squared is just x. The square root of 36 is 6. And then one thing you need to consider that I think we've talked about is that there are actually two answers to this. 6 times 6 is 36, but negative 6 times negative 6 is also 36. So we have a symbol called plus and minus. And right here is my answer that I got incredibly quicker than I did when I factored. Factoring is still completely appropriate, but if my equation is this simplistic, I can think about the square root idea. And that's really what this is all about today, is solving quadratic equations by taking the square root. Okay. Now there is one important thing to this. So when we solve using the square root, there are two important components. One, the squared term must be isolated. The other is that there should be two answers or solutions. One of them will be positive, one of them will be negative. So this is what we're looking at. So now we just look at different variations of what the equations could possibly be given to you as. So if we were to do something like x squared equals, 81, okay? I can notice the format. The x squared term is isolated, so I can simply do the square root. The square root of x squared is x. The square root of 81 is both positive and negative 9. There are my answers. Okay. if I were to do something like 2x squared equals 128. So this was number 1. This is number 2. Okay, let's go back to the 2 requirements. The first requirement was to make sure that the squared term is isolated. Right now, it is not. So to get that squared term isolated, I would divide both sides by 2. That would give me x squared equals 64. Now that I notice that the x squared term is isolated, now I can do the square root. The square root of x squared is x. The square root of 64 is both positive and negative 8. Again, it would have worked to subtract 128, take out a GCF of 2, and then factor by difference of perfect squares. I would get the exact same answer, but this is more efficient. And please recognize once again what's not there. There was no regular x term. There's just x squared and a number. Now, please consider that that number doesn't always have to be a perfect square like it was in these two. So if I was to look at something like x squared equals 40, okay, it doesn't change the way I try and attempt this problem. I see that the x squared term is isolated, so I'm still going to do the square root. The square root of x squared is x. The square root of 40, well, 40 is not a perfect square. So now I use the ideas that I did the other day to simplify an irrational square root. I know that 40, so the square root of 40, is equal to the square root of 4 times 10, which means that this is 2 times the square root of 10. So that means that x is both the positive and negative versions of 2 times the square root of 10. That, by the way, could not have been done by difference of perfect squares because 40 is not a perfect square. But I would like you to check something out. If you go to your calculator and do 2 times the square root of 10, and then multiply that by 2 times the square root of 10, you should get 40. Try the same thing with the negative version, and again, it should work out. Okay? So, if I was to give you something like x squared equals 45, okay, pause it if you know what to do, but what I would do is square root. This would give me x. 45 is not a perfect square, so I would keep in mind 45 is the square root of 9 times 5, which is really equal to 3 times the square root of 5. Okay, so that means that x is the positive and negative 3 square roots of 5. There are my 2 solutions. Okay, so now all we do is we start putting different variations on that. So maybe I do something like x squared plus 12 equals 92. Well, think about everything that you had done in the past. I would start by subtracting 12 from both sides. That would give me x squared equals 80. Well, that's cool. Now x squared is isolated, so now I would do the square root on both sides. Square root of x squared is x. Square root of 80, once again, 80 is not a perfect square. So I think about the square root of 80. Yes, it's 8 times 10, but neither of those are perfect squares. So I try that list that I should be creating out. And I see that 16 goes into 80. It's 16 times 5, which means that the square root of 80 is equal to 4 times the square root of 5. Okay? So if x squared is 80, then x is going to be the positive and negative 4 square roots of 5. And that's it. Okay? That really is the lesson here. So I will just give you a couple to attempt and come into class ready with any questions or concerns or whatever you might need. So let's have you do x squared. Let's do 3x squared equals 48. Okay, and then let's also do x squared plus 12 equals 92. All right, See what you get for those, and I will see you in class tomorrow. Bye-bye.